Hi, this is Mike Lopez, and in this video we're going to be examining power series methods. Now, in able to formulate your own power series, you need a reasonable understanding of calculus. However, calculus is not covered really until learning outcome 3 or assignment 3, whichever way you like to term it. And for those reasons, what we really just need to do now is to state some power series and use them. Okay, so let's have a look at an example. How about the COS of X? We use our power series methods and notation, and we should end up with something like this. COS of X is roughly equal to 1 minus x squared over 2 factorial, which is 1 times 2, plus x to the 4 over 4 factorial, which is 1 times 2 times 3 times 4, minus x to the 6 over 6 factorial, which you now know to mean 1 times 2 times 3 times 4 times 5 times 6. And you should have a factorial button on your scientific calculator somewhere. Have a look and see. Plus, blah, 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 and we can go on in that fashion. Obviously, the next one is going to be x to the 8 over 8 factorial, etc. Okay. Why don't we let x equal 0.5? Okay, so we're going to fit 0.5 into all of these x's here. But when we do so, I'll just change colour and make a very bold note here. This 0.5 is expressed in radians. It's very, very important. Okay, it's radians. It doesn't work in degrees. So expressed in radians, not degrees. So that means put your calculator into radians mode. Normally by default, calculators will be in degrees mode. And another thing that we can do, why don't we work to 5 decimal places, or if you like, dPs. Okay, so that gives us our level of accuracy. So let's begin then with this development. So we're looking at the COS of 0.5. And we look in the power series up here, and we say it's roughly equal to 1 minus 0.5 squared over 2 factorial, which is 2, plus 0.5 to the power 4 over 4 factorial, which is 1 times 2 times 3 times 4, which is 24, minus 0.5 to the 6 over 6 factorial, which you can work out to be 720. And then of course you could go on forever, but we'll just write it like this. Okay. Now we need to work those things out. So that's roughly equal to 1 minus 0.5 times 0.5 is 0.25. 0.25 over 2. 0.5 to the power 4 up here is 0.0625, sits over 24, minus 0.5 to the 6 works out to be 0.01563. If you work it out to 5 decimal places, that sits over 720, plus some other bits if we care to do them. And I think you'll find when we work this thing out, it has very good agreement with what a calculator will say. Okay, so we managed to get all of these Let's evaluate all the fractions. So we got 1 minus, that's going to be 0.125 plus, this is going to be 0.0026, and this is going to be minus 0.402. Okay, and if you add all that up, you get 2. Therefore, the COS of 0.5 is roughly equal to, in this power series way of analysis, that minus that plus that minus that comes to 0.87758. Okay, and again, that was to 5 dp's, or 5 decimal places. Right, let us check on a calculator. And in brackets, just emphasize once more, radians mode, because you're going to have a completely different answer if you put it in degrees mode. We actually get 0.87758. Again, we've rounded it to 5 decimal places. Okay, and obviously what we have here is very good agreement. Between our analytical method and our calculator method. Excellent. Okay, let's move on and have a look at another example of power series methods. This time we'd like to look at the binomial series. So the binomial series expansion. Okay, and it's just another example of more power series, because there are powers of X in the answer. And in general, what we can say for power series expansion is some constant a plus x to the power n can be written as a to the n plus n lots of a to the n minus 1 lots of x plus n lots of n minus 1 a to the n minus 2 x squared all over 2 factorial plus n lots of n minus 1 times n minus 2 times a to the n minus 3 x to the 3, all sitting over 3 factorial plus, and then you go on forever until it falls away to 0 over on the right hand side, of course. Quick example, let's use that. Let's therefore expand this thing. How about 4 plus x all cubed using binomial expansion? Or if you like, the binomial series, same thing. Okay, so I'm going to have a look at doing this. I'm going to write it down, 4 plus x all to the 3, And we look upstairs here, so we're following this thing, a to the n. Well, a is the 4, okay, n is 3. Maybe we could put that in, so I'll change colours. That thing there is a, and that 3 there is n, okay. So get back to red, we're going to have 4 to the 3 is that one, and I'm looking at this thing here now, and I'm seeing plus 3 lots of, put it in brackets for safety, 3 lots of a to the n minus 1. Okay, well, a of course is 4 to the n minus 1. Well, n is 3, so we just write it as 3 minus 1. Just take it step by step. Lots of x, so we just put x in. Plus, now I'd like to deal with this lot here. Okay, so again, I'm putting n in there. N is 3, so I'm going to have 3 lots of n minus 1, that's 3 minus 1, a to the n minus 2. Okay, and what's the value of a? It's 4. 4 to the 3 minus 2. I need to put that x squared in there as well. Okay, so x squared goes in, and it all sits over 2 factorial, which is just 1 times 2, which gives us 2. And trying to use as much of the available space as we can now, plus n lots of n minus 1, n minus 2, n minus 3, because we're dealing with this thing here. Okay, so n is 3, so it's going to be 3 lots of 3 minus 1 times 3 minus 2 times a to the n minus 3, okay, and remember a is 4, so that's going to be 4 to the power 3 minus 3 times x cubed, all over 3 factorial, just 1 times 2 times 3, which is 6. Now I don't need to put plus dot 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 in this area anymore, because what we would realize is one of these brackets would be 3 minus 3 on the next term, so 3 minus 3 is 0. 0 times anything is 0, so that's why everything disappears in this particular case. Okay, so all we need to do now is to tidy up a little bit, work out what all these things are. This thing here, it's 4 by 4 by 4, 4 4s are 16, 4 16s 64. Okay, and we have the x terms, 4 to the 3 minus 1, so that's 4 squared is 16 times the 3 gives you 48. 48 lots of x. Okay, evaluate all this lot here, and we get to 12 lots of x squared. And we do the same with this lot here, and we should arrive at a nice simple x cubed. Okay, and they're all done in the same way. Okay, I'll see you in the next video.